Hi students, welcome to Python Programming Lab course. I am Dr. K.Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In this session, we will see week 3 programs. In week 3, we have 4 programs. So, largest of 3 numbers, so primary numbers, so factorial using recursion and find student average and percentage. Overview of the presentation. In this session, we will see 4 programs. So, first program regarding finding the largest of 3 numbers. Second program, print primary numbers between 50 and 100. Third program, factorial calculation using recursion. Fourth program, so finding average percentage based on student marks. Outcome of this lecture: at the end of this lecture, student will be able to implement functions to perform specific tasks. In this lecture, we are going to see that so finding the largest of 3 numbers, we define this task as a function, and you are able to use loops and conditional statements to identify and print prime numbers within a range. You understand that how to use the conditional statements like if, else, and loops like for loop. Okay. Apply recursion to compute the factorial of a number efficiently. Here you learn how to apply the recursion. And develop logic for real world scenarios such as calculating average marks and percentage based on subject scores. Improve problem solving skills by writing structured and efficient Python programs. These are the outcomes of this lecture. So program 1 is write a Python function to find largest of 3 numbers. Now here the program should accept 3 numbers as input from the user. So for example, if I give input like this 10, 15, 8, 3 numbers. Compare the 3 numbers using conditional statements. Use if, else. Okay, if A greater than B and A greater than C, then A is big. Else if B greater than A and B greater than C, then B is big. Else C is big. Okay. And determine the largest number among 3 inputs. Yeah. So based on these numbers, 15 is the biggest number. So this number we return and display this as a largest number. Okay. So let us see the program. So this is the program to find largest of 3 numbers. Here we are taking 3 inputs n1, n2, n3. Now for example, if here I am giving the numbers 10, 15, 8. So 10 is assigned to n1, 15 is assigned to n2, 8 is assigned to n3. So n1 equals to 10, n2 equals to 15, n3 equals to 8. Now I call the function find largest. So find largest is function name. Now this function will return some value. That value we are assigning to the largest. Okay, now so this is the A 10, 15, 8. So equals to 10, B equals to 15, C equals to 8. Now compare. So 10 greater than or equals to 15 and 10 greater than or equals to 8. So 10 greater than or equals to 15 is false. Then go to else if. What is else if? B greater than, that is a 15 greater than or equals to 10 and 15 greater than or equals to 8. Yes, both the conditions are true. So return B. What is the B value? 15. Now 15 is assigned to the variable largest. Now we print that the largest number is largest, that is 15. Okay, so let us execute this program. So enter the first number. I'm entering 10. Enter second number 15. Enter third number 8. The largest number is 15. Let us see another case. So enter the first number 15, second number 10, so third number 25. Now the largest number is 25. Third case, enter the first number 45, second number 34, third number 23. Now the largest number is 45. In first case, so B is the largest number 15. Second case, C is the largest number 25. Third case, A is the largest number, that is 45 here. Okay. Second program, write a Python function that prints prime numbers in between 50 and 100. The purpose of the program is we are going to print the prime numbers from 50 to 100. Okay, so define a function to check whether number is prime. Iterate through numbers in the range 50 to 100. Here they mention the range is 50 to 100. So we run a loop. The starting value is 50 and the last value is 100. So use the prime checking function to identify prime numbers. That means the starting number is 50. Now by using this prime checking function, you are going to check that the 50 is prime number or not. Okay, after 50, 51, 52, up to 100. Okay, and finally print all prime numbers within the given range here. In this example, the range is 50 to 100. Okay, so let us see the program. So this is the program to print prime numbers in between 50 and 100. So this is the function call I call. The function name is print primes in a range 50, 100. Now this function will invoke. So print prime numbers. What the start here? 50. End is 100. Now we are iterating the loop using range function. Range start is 50. N plus 1 means 101. So range is a function we use for iteration. For example, here in this case 50, 100 you are specifying as a start and end. So the iteration starts from 50, next 51, 52 up to 100. Okay, so now here we are using another function is prime. Is prime. Now is prime, in first iteration the num equals to 50 here, 50. Now we call the function is prime, n equals to 50. Now for I in range of 2, int of n power 0.5, this equals to root of n. Now here we remember, so for example to know, so 1001 is a prime number or not. How we know that means? Except 1 and 1001 and the remaining numbers are 2 to 1000. If you try to divide this number with these numbers from 2 to 1000, it takes 999 times we enter into the loop. So it is time consuming. There is another alternative is take any number, find the root value, root. For example, for 1001, the value is around 31. Now, if we check the numbers from 2 to 31, then if this number is not divisible, then we say that this number is prime number. Okay, to find 17, 17 is a prime number. To check the 17 is whether the prime number or not means you can start from 2 to 16. But if you use this formula root, that means what is the root of 17? Root of 17 equals to 4 point. Now if you check 2 to 5, 2 to 5, then this is enough to confine the 17 as a prime number. Okay, so here you can write 2 to n or 2 comma root of n. Okay, root of n means n power 1 by 2. This we represent like this. Okay, now for I in range of 2 comma root n plus 1. So why we are changing the int means we are getting some float value. So we convert that float value into the integer plus 1. Here in this case we will get the 4-point value. So consider this int part 4 plus 1, 5. So it is 2 to 5. Okay. Now n percentage I equals to 0. So consider 17. In first case it is 2. So what is the n value? 17 percentage, what is the I value? 2. 17 percentage 2 equals to 0? No. So next iteration 17 percentage 3. Next iteration 17 percentage 4. Next iteration 17 percentage 5. Now the loop is over. Then we return the value true. Now it returns the value true. So here print 17. Okay. In this case the range starts from 50 to 100. Okay. Every time you take one value and check whether the number is prime or not. Okay. So let us execute this program. So these are the prime numbers between 50 to 100. 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So 4 is not a prime number. How means? We enter into the loop here. What is the n value? 4 percentage I value 2 equals to 0. So we return false now. False means it is not a prime number. Okay. Program 3. Write a Python program to find factorial of a number using recursion. So factorial means, for example, I want to know the factorial of 5 means 1 into 2 into 3 into 4 into 5, or 5 into 4 into 3 into 2 into 1. Okay. So 1 into 2, 2. 2 into 3, 6. 6 into 4, 24. 24 into 5, 120. Okay. The program should accept a number as a input from the user. In this case, the number is 5. Use a recursive function to calculate the factorial of the number. So don't use loop here. Here this clearly mentioned that using recursion. So here, so base case is return 1 if the number is 0 or 1. For example, what is the factorial of 0? 1. What is the factorial of 1? 1. What is the factorial of 2? 2. So use this 0 or 1 as a base case. If the number is 0 or 1, then return 1 here. So recursive case. So multiply the number by the factorial of n minus 1. What it means? For example, if I want to find the factorial of 5 means 5 into 4 factorial. For 4, 4 into 3 factorial. For 3, 3 into 2 factorial. For 2 factorial, 2 into 1 factorial. Here we mentioned the base case. If it is a 1, then return 1. So 2 into 1, that is a 2, that is written here. So 2 factorial is 2. Now 3 into 2, 6, that is written as a 3 factorial, 6. 4 into 6, 24, that is written to here, 4 factorial is 24. Now 5 into 24, 120, this is the answer. Okay, this we called as a recursion. Okay, so finally display the calculated factorial as a output. So let us see the program. So this is the program for factorial using recursion. Here we read one value from the keyboard that is assigned to a variable num. For example, the value is 5. Then I call the function factorial with the value 5. The 5 is assigned to n here. So what is the n value? N equals to 5. Now check what is the base condition. N equals to 0 or n equals to 1. then return 1. But here what is the value? 5. So 5 equals to 0? No. 5 equals to 1? No. So enter into this else block. What is the else here? Here else we return as a return n. What is the n value? 5 into factorial of 5 minus 1, that is a 4. So we don't know the value of factorial of 4. So again same function called. What is a recursion? A function calling itself is a recursion. If you observe here, the function name is factorial. Here the function name is also factorial. That means same function calling the same. So this concept we call as a recursion. Now what is the factorial of 4? We don't know. So we call the function factorial. What is the n value now? 4 now. Now n equals to 4 in this case. Here n equals to 5. Now 4 equals to 0? No. Or 4 equals to 1? No. So enter into the else block. Again return 4 into fact of 4 minus 1, that is a 3. So again we call the function factorial. Now what is the n value? 3. 3 equals to 0? No. 3 equals to 1? No. So we enter into the else. Again return 3 into factorial of 3 minus 1, 2. So again the function called. Now the n value becomes as a 2. And 2 equals to 0? No. 2 equals to 1? No. So enter into this else block and return 2 into, so factorial of 2 minus 1, 1. So again function called fact of 1. Now n equals to 1. Yes, in this case n equals to 1. So this condition will true and return 1 here. That means the total value of this function is become as 1 now. Now this 1 will return to the called function. Now this 1 will return to this called function 1. Now 2 into 1, 2. Again this value 2 is returned to called function. Now here this is the called function. Now this 3 into 2 become as 6. Again this 6 is returned to called function. Here 6. 4 into 6, 24. Now this 24 will return to called function. Here 24. Now 5 into 4, 120. So this will return to this function and assign to this result. Now result equals to 120. We print that the factorial of 5 is 120. So let us execute this program. Now here I am entering 5. The factorial of 5 is 120. Okay. So program 4, write a function that receives marks received by a student in 6 subjects and return the average and percentage of these marks. Call this function from main and print the result in main here. The program should accept marks for 6 subjects from the user, calculate the total marks obtained, compute the average marks by dividing the total by the number of subjects and determine the percentage based on a maximum of 100 marks per subject and display the average marks and percentage as output. So let us see the program. So this is the program to find student marks and average. Here they clearly mentioned that the function will call from main and print the result in main. So outside the functions, what you are writing, that we consider as a main. But when you import these Python files in another file, then also these statements will be executed. So that's why sometimes we clearly mention the main also. Here in program, they specified clearly that they mentioned main as a function. So here I am defining the main here. So def main. Okay. Now we call the function like this. If name, this is the special variable, underscore underscore name underscore underscore, that equals to main. If this is the main, then we call the function main here. Okay. If you are executing only the one program, maybe you are not able to identify the any difference. But if you import this file, so for example here the program name is week3p4.py. If you import this program in another program, then we observe some difference here. Okay, so now here I am taking one list, empty list. Now I want to store all the marks in the list here. How many subjects? 6 subjects. Okay, so 6 times we enter into the loop. So we write for I in range of 6. That means 6 times we enter into this loop and execute these 2 statements. Marks, I write here enter marks for subject I plus 1. What is the I value initially? 0. 0 plus 1 means 1. So it displays enter marks for subject 1. Now if I enter 85.2, that is assigned to mark. Now this mark I want to append to this marks. Initially it is empty. Now 85.2. In next iteration, again it prints enter marks for subject 2 now. Why? I is incremented. So I previously it is 0. In next one 1. 1 plus 1 2. Now I enter 98.3. 98.3. Similarly, I enter all the 6 subjects 65.0, 85.4, 93.2 and 85.0. Okay, now so these values are stored in a list called marks. Then I call the function calculate average and percentage. So this is the function name. Now what is the input here? Input is the list. Now this list is assigned here, and for total marks we are using one function, predefined function sum. Otherwise you can calculate using the for loop also. Okay, here I am using sum. Now the sum, these marks are assigned to a variable total marks. Now I am going to find the average. How we find the average? Total marks by subject, number of subjects. Here the number of subjects are 6. So here we are finding the length of marks. That means 6 items already stored in marks, so it becomes as a 6. Okay, so percentage equals to total marks by 6 into 100 into 100. So it returns percentage value and stored in the variable percentage. Then finally we return average and percentage to called function. What is the called function here? Main is a called function. Now the values are assigned to AVG and percent. Okay, now we are printing average marks equals to average dot 2f. So dot 2f means, for example, the number is 38.4534. Now I want to print up to 2 digits only, 38.45. In this case we are going to use 0.2f. F means float, 0.2 means I want to print 2 digits after dot. Okay, so similarly percentage, so percentage colon dot 2f, that means I want to print 2 digits after dot value. Okay, so let us execute this program. Say enter marks for subject 1, 78.8. Enter marks for subject 2, 76.5. Enter marks for subject 3, 45.67. Enter marks for subject 4, 65.7. Enter marks for subject 5, 66.9. Enter marks for subject 6, I am entering 90.8. Now if I press enter, so this is about average marks and percentage. Okay, so coming to summary of the session. In this session we learn 4 important programs, and the first program regarding, so find the largest of 3 numbers. So in this program we used conditional statements to compare and determine the largest number among 3 numbers, 3 inputs. And second program regarding prime numbers between 50 and 100, implemented a function to check for prime numbers and printed all prime numbers in the given range using loops and conditions. So third program, factorial of using recursion, explored the concept of recursion by writing function that calculates the factorial of a number. Fourth program regarding the student marks, finding the average and percentage. So finding the average and percentage calculation. So designed a function to take marks of 6 subjects. and compute the average and percentage and display the result. So this is about today's session. We will meet in next session. Thank you.